Welcome back from break, everyone. I hope everyone had a great lunch. I think we're just going to hop right into the next presentation. I'd like to invite the next speaker from Sempra up. It's going to be on emission reduction strategies. Are you going to be on? Okay. Oh, yours.
All right, well, good afternoon, everybody. First of all, I want to say great job to everyone that has presented already. Everything's been very interesting and really well put together, so some nice work. Again, my name is Josh Stanford. I'm a program and project manager at SoCalGas and SDG&E. And the topic of this next presentation is SoCalGas emission reduction strategies. And so in this presentation, we're going to cover 4 of the strategies that have been most impactful in reducing emissions for for SoCalGas. There we go. And between 2018 and 2024, these 4 initiatives have helped SoCalGas to reduce about 6.4 billion cubic feet in natural gas emissions. These are not in any particular order, but the first will be blowdown reduction activities, followed by leak inventory reduction, increased leak survey, and aerial monitoring. After discussing these 4 key strategies, we'll discuss some opportunities for emission reductions in the future, as well as some opportunities to refine our emissions estimates to be more accurate in the future. And then we'll close with an emission reduction program outlook for SoCalGas. And so the first key program we're highlighting is blowdown reduction activities. This program has been a cornerstone in SoCalGas's emission reduction strategies. It started in 2018, and between 2018 and 2024 was responsible for 1.4 billion cubic feet in natural gas emission reductions. Those are illustrated here in the figure at the bottom right. And so this program helps to reduce emissions through a variety of methods, including gas capture, cross compression, and drafting. And through this toolbox of reduction strategies, we're able to really effectively reduce the volume of gas that is emitted during transmission pipeline blowdowns. In fact, during 2024 calendar year, we reduced the volume of transmission pipeline blowdowns by 95%. Looking forward into the future for this program, we are anticipating sustained emissions reductions during 2026 and 2027 because Resolution G3605, which was issued in response to our 2024 compliance plan and covers years 25 through 27, fully authorized our blowdown reduction activities. This is also a program that's very cost effective, where we are forecasting a break even or better standard cost effectiveness over the next several years. The second key initiative is leak inventory reduction. And so before the SB 1371 program and the best practices, SoCalGas would repair non-hazardous main and service line leaks in accordance with compliance timeframes. But with SB 1371 and Best Practice 21, which is find it, fix it, SoCalGas begins trying to repair these leaks ahead of those compliance timeframes to reduce our emissions. And so we kick off these efforts in 2020, and we start by focusing on the oldest leaks first. By the end of 2020, we achieve a 32-month inventory, which means the oldest leak in the inventory at that time is 32 months old. In 2021 and 2022, we advance further and achieve a 24 and a 13-month inventory. Now for 2023, because we had already achieved the 13-month inventory, which is quite small, we begin pursuing average repair times. And so in 2023 and 2024, we achieve 8-month average repairs for those non-hazardous main and service line leaks. Through this work from 2020 to 2024, we reduced 1.8 billion cubic feet in natural gas emissions. And those are illustrated in the figure here at the right. Now for 2025, we have some preliminary data that suggests we achieved a 9-month average in our repair times for these non-hazardous main and service line leaks. And so you're probably wondering, why did you go from 8 months to 9 months? And the reason is that in 2025, Resolution G3605 was issued in response to the 2024 compliance plan. Resolution G3605 did not authorize us to continue the leak inventory reduction program at the same level as we had in prior years. And so we see a slower average repair time for 2025. Because Resolution G3605 covers 2026 and 2027, we're also anticipating a slower average repair time during those years as well, and a corresponding increase in emissions from Appendix 4 main and service line leaks during each of these years with the slower average repair times. However, we are leveraging our large leak prioritization program to maximize the emissions that we can gain through this program and hopefully minimize these near-term increases that we are forecasting. As we look forward into the future and into 2028, we are estimating that this program is going to see a significant improvement in cost effectiveness. This is due to a couple key factors. The first is some efficiencies that we've made in the program over the years. But secondly, we are now separating the GO112F compliance costs from the incremental leak abatement program SB 1371 related costs. And we're only using the latter to estimate cost effectiveness. Those GO112F compliance costs are separate from the leak abatement work. They will be incurred regardless of whether there are activities under the leak abatement program, and therefore they should be separated from those standard cost effectiveness calculations. In addition, in 2028, we are hoping to reverse some of these near-term increases in emissions by potentially reinstating work under the leak inventory reduction program. And in our test year 2028 GRC, we plan to propose to reinstate some of these activities to again, try to reverse some of these near-term increases that we're anticipating. And so we've had some success with reducing emissions by repairing leaks quickly, but we've also had some success in reducing emissions by finding leaks more quickly. One such program is the increased leak survey program. So work begins under this program in 2018 when we accelerate surveys on vintage plastic from 5-year to 1-year cycles, and we advance further in 2020 when we accelerate surveys on unprotected steel from 3 to 1-year cycles. Through this work and continued acceleration from 2018 to 2024, we reduced 2 billion cubic feet in natural gas emissions, illustrated at the bottom right. And so as we look forward into future years, we do anticipate that we will continue the accelerated surveys on vintage plastic, but we have decelerated surveys on unprotected steel beginning in 2026 due to Resolution G3605. Resolution G3605 did not continue or did not authorize us to continue this work during 2026 or 2027. Because we have decelerated surveys on unprotected steel, we're also expecting there will be a corresponding increase in emissions, likely in the Appendix 4 unknown leaks as well as Appendix 6 unknown leak sections, because we're not covering as much mileage with our surveys. So we'll be likely extrapolating and estimating more unknown leaks. Now, we are hoping that in 2028, we can potentially offset or reverse some of these near-term increases through an aerial leak detection program. That leads into the next topic, which is aerial monitoring. And so with this program, we reduce emissions by flying a helicopter over our service territory. The helicopter has methane detection equipment attached to it, and it, of course, finds methane emissions throughout SoCalGas infrastructure, but also on customer infrastructure. We then follow up on the ground to mitigate the emissions from SoCalGas infrastructure and notify customers of those emissions that are on their infrastructure. The program kicks off in 2021, and mind you, 2021 is a partial implementation year due to some challenges related to the pandemic. But between 2021 and 2024, we're able to reduce 1.2 billion cubic feet in natural gas emissions with this program, and that's illustrated here in the chart at the bottom. And so the reason why we were able to reduce such a significant volume in just 4 short years, and one of them being only a partial implementation year, is because this mitigates emissions from SoCalGas, but also from customer infrastructure. We're finding leaks on mains and services, but also on house lines, yard lines, customer appliances, so on and so forth. And so there are a number of sources where we can mitigate emissions with this program. Now, looking forward into future years for 2025 through 2027, we have paused this program because Resolution G3605 did not authorize us to continue during those years. And because the program is paused, we are anticipating increased emissions from SoCalGas as well as customer infrastructure during those years. Now, looking into 2028, we are, or let me take a step back. However, because this program has been so impactful in terms of reducing emissions, but also in enhancing safety for our customers by finding leaks and emissions on their infrastructure, as well as promoting affordability for customers by, again, finding leaks and emissions on their infrastructure. We do plan to propose this in our 2028 GRC for continuation. And we are also estimating that in 2028, this program will either be at a break-even or better standard cost effectiveness with SoCal gas emissions only. And this is notable because in prior years, we would hit break-even or better standard cost effectiveness, but only with SoCal gas plus customer emissions. But now we're forecasting that SoCal gas emissions alone will help us to hit that break-even or better standard cost effectiveness. And that's because we've decelerated surveys on unprotected steel, which means aerial monitoring now has a significantly larger potential to reduce emissions, enough so to push us to that break-even or better standard cost effectiveness threshold. And so we're looking forward to the opportunity to potentially reinstating this in 2028. And that segues into the next item here, which is opportunities for emissions reductions. As I've mentioned several times so far, there are some opportunities here in the future to reduce emissions by reinstating key programs, namely leak inventory reduction and aerial monitoring. As we've discussed, these are tried and true programs with established track records. They also have established processes and years of innovations and enhancements under their belts, and they are both expected to have improved cost effectiveness in 2028. The second opportunity here is with our large leak prioritization program. So this program helps us identify leaks that are likely emitting more than other leaks. Once we know which leaks are emitting at the highest volume, we can prioritize them for repair and hopefully maximize the reductions that we can gain through those leak repairs. And so we're trying to fix those potentially large leaks as fast as we can. The third and fourth items here are related to compressor rod packing emissions. And so the first item that we're considering is strategic implementation of vapor recovery systems at select compressors within our compressor station network. We have about 40 compressors throughout the compressor station network. It would be costly and potentially not cost effective to install vapor recovery on every single one of them because some don't emit very much. But we're considering installing vapor recovery on the 3 that have historically emitted at the highest rates. In doing so, we estimate that we could reduce annual compressor vented emissions in Appendix 3 by about 15%. And with these vapor recovery systems, the emissions for those compressors are effectively reduced down to 0. And the recovery systems last decades, so potentially bringing lasting reductions to those compressors. Similarly, we're considering enhanced quality and maintenance plans for our compressor rod packing. And so this idea was sparked partially by an external study. There was a study that showed facilities with enhanced quality and maintenance plans had 66% fewer rod packing emissions than those that only focused on replacing the rod packing rather than implementing these quality and maintenance plans. And so we did a case study internally on 5 of our compressors, and we saw that the average reduction before and after in implementing these enhanced quality and maintenance plans is about 60%. And so we're considering implementing this on a wider scale to reduce Appendix 3 compressor vented emissions, as well as Appendix 7 compressor vented emissions. And so these are just 4 opportunities that we're highlighting today. There are, of course, others out there. This is not exhaustive. And I know Eric is going to share a few really intriguing and promising ideas that are in R&D in the next hour or so. And speaking of potential improvements and refinements within the leak abatement program, these are some areas where we think the emissions estimates could be refined to be more accurate. And so the first, I think folks are pretty familiar with this. In Appendix 1, we are estimating the leak emissions from transmission pipelines through mileage-based emission factors. It would, of course, be more accurate to transition to leaker-based factors. There are a few avenues towards achieving this. We could develop company-specific factors, or similar to what we did in Appendix 2, we could leverage maybe a national factor or some peer-reviewed literature or data to establish those factors. So there are a few routes, but the main point is that transitioning from mileage-based to liter-based would, of course, be more accurate. Secondly, and I think folks are familiar with this to some degree as well, but establishing company-specific emission factors for venting devices would help us to more accurately estimate emissions from those devices. We've done some work on this at SoCalGas. We don't have enough measurements to establish the factors, and we weren't authorized to continue this work in 2025 through 2027. But in the future, we could potentially collect the additional measurements and establish these factors for Appendix 2, and this may apply to Appendix 1 or 3 as well, as those are all transmission segments. The third item here for potential refinements is the Appendix 4 unknown leak framework. And so this idea for refinement was sparked by a couple different initiatives: aerial monitoring and basically mobile monitoring. And so within the current framework, an operator could extrapolate and estimate unknown leaks and unknown emissions for a part of their territory that they are also flying mobile surveys over or driving mobile surveys on. And so in that case, you'd be estimating unknowns, but also technically surveying it either via air or ground. And so there's a potential for overestimating your leaks and your emissions. So perhaps there's a way that we can offset those supplemental survey findings within the Appendix 4 unknown leak framework to avoid that kind of overestimation. And this idea was sparked, or one of the things that got us to think about this a lot recently was a pilot that we're working on with USPS. Eric will talk a lot more about this, but we have some USPS vehicles that have methane detection equipment attached to them. They are passively surveying our lines during their mail routes every day. This is still just a pilot, but if that becomes a wider implementation or service area wide adoption, we could conceivably have USPS vehicles conducting mobile surveys during their mail routes 5 to 6 days a week, 52 weeks a year. And in that case, with the current framework, we would still be estimating unknown leak emissions for the very roads that they're driving every week. And so again, there's this potential for overcounting or overestimating unknown leaks and unknown emissions in those types of situations. I will close by saying these are just some ideas and some suggestions to potentially refine the estimates in the future. These are not proposals right now or anything that we're suggesting to implement for this year, but more food for thought than anything else. And that brings us to the final slide here, the emission reduction program outlook for SoCalGas. So as we've explained on several slides so far, we are anticipating a near-term increase in emissions due to resolution G3605. However, a reversal to this near-term increase is possible following the test year 2028 GRC decision, because we plan to propose to reinstate several of our key initiatives, such as aerial monitoring and leak inventory reduction. And because these programs would be in the GRC, they would be separate, and the requirements or the constraints of the compliance plan and leak abatement program and process would not apply to them, meaning they could be assessed based in part on the substantial emissions and environmental benefits they bring, but also based on the safety and affordability benefits that they bring to our customers. And so as we look forward with our emission reduction efforts and leak abatement program, the biggest risk that we see to sustaining the current level of emissions reductions will be the disallowance of previously approved or existing programs. But nonetheless, we are very proud of how far these key programs and initiatives have come over the years, and we look forward to the opportunity to potentially continuing them into the future, as well as continuing to explore additional cost-effective solutions for emissions reductions. Are there any questions?
Yeah, hi, Josh. Can we anticipate some of those things to be coming up in your currently being prepared compliance plan for this year? I think there's
Absolutely.
a few. Yeah.
Yep.
We look forward to seeing those and appreciate getting a sneak preview of what.
Yeah, absolutely. Thank you.
Renee Guild, thanks for joining us. Renee's got her hand up. Please go, Renee.
Hi, I'm Renee Guild with Gas Policy and Reliability in the Energy Division, and I want to first of all thank you, Josh, for a very interesting presentation. I had a question concerning how that works, that you're focusing on the plastic pipe will improve your cost effectiveness. Is that because you're focusing on a smaller amount of pipe, and you're not doing the unprotected steel, or how does that work?
Hey, Renee. So are you asking about the AMM or the aerial monitoring cost effectiveness?
Yeah, I think it came up with that, right.
Sure. So we're anticipating improved cost effectiveness with an aerial monitoring program because we've decelerated the survey cycles on unprotected steel. They were formerly 1 year, now they are 3 years. And so the potential for an aerial monitoring system or program to reduce emissions has grown substantially because before the most that we were gaining was 1 year, right? We could have been finding a leak 1 year earlier than we would have found it on a walking survey. But now if those walking surveys are on 3 year cycles, we could be finding it 1 year earlier or potentially 3 years earlier at the far end of the spectrum. And so that brings in a lot more potential to reduce and improves our cost effectiveness.
Okay, good. Um, and I applaud your focus on cost effectiveness. This was a very tough decision for the commission, as you may know, and we really are trying to work with you to improve cost effectiveness, as well as, of course, Fred and his teams. So continue that. Appreciate it.
All right, we appreciate it. Thank you. You're welcome.
Looks like Wynn's got his hand up now. Go ahead, Wynn.
Thank you, Fred. Josh, if I can say, the best slides that I saw today are the one you just presented, okay? Because this give us a roadmap of what you're trying to accomplish in the future. But here are several questions that I would like to ask you on slide number 3.
Sure.
Okay, you identify 1.5 billion standard cubic feet reduced from blowdown, correct?
Correct.
Can you explain most of this blowdown coming from what kind of source? Maybe, let's say, because you're repairing a major pipeline, or because there is a testing that you need to do. Can you recall what are the major sources of this emission reduction from blowdown?
Sure. So these are transmission pipeline blowdowns. So there are a variety of reasons. I don't know all of them, but it could be maintenance related items, or there are some that can be reduced related to inspections as well. I don't know what contributed to all of them, but it would have been from the high pressure transmission pipelines.
Okay, I completely agree with you. Blowdown from transmission pipeline, I consider that one low hanging fruit. Okay.
Yeah.
Absolutely.
In one location, you can save a lot of gas rather than spread all around your jurisdiction. This one specific one. Okay, so like a point source. So I would applaud you to keep doing that. And then as you know, maybe down the road, you have less and less blowdown going to occur. So maybe not as a major source of your emission reduction. And then on the next slide, okay, okay, the last bullet, anticipating improved cost effectiveness in 2028, you mentioned 2 sources. Okay, one is the efficiency of your survey and repair, and then second, can you explain again related to SB 1371 and then GO something that I didn't quite catch?
Absolutely. So in prior compliance plans, we calculated cost effectiveness using the total costs for non-hazardous main and service line leak repair, which would include GO 112F compliance costs. Those are, of course, separate from leak abatement. They are the requirements that we have to repair those non-hazardous main and service line leaks within certain established timelines. And then there are costs associated with accelerating the repairs faster than those timelines to reduce emissions. And so we're separating those two. There's a bucket that is compliance costs that we would have to incur whether there are any leak abatement program projects or requirements, right? There are GO 112F requirements that we must follow. And then there's a separate bucket of costs which are associated with this leak abatement program and the intention to reduce emissions. So we brought out those costs that would be incurred for compliance purposes, separate from SB 1371, because it really isn't accurate to count those in our cost effectiveness calculations, because this is cost effectiveness of the incremental work that we are proposing under SB 1371. It's not the cost effectiveness of this incremental work plus the work that we are required to do for other compliance purposes.
Okay, that one is GO F112 or just GO 112?
I'll explain. This is a commission general order. So the GO stands for a general order, and it's number 112F,
Okay.
the F version of that general order. And these are the general safety rules for operating gas pipelines in the state. And Josh is absolutely right that you really, those are required to be done no matter how cost effective they are. They just have to be done. And previously, SoCal kind of lumped all that. It's probably easier for you to do cost accounting. I'm just saying all of my leak repairs, all of those costs, right? But now you're recognizing that it would be more illustrative of the NGLA program to separate costs from compliance requirements and 1371 incremental. Yeah, I got it. Totally applaud your effort there. Thank you. Did that explain it, Vin?
Yeah, but my question, by separating that, will you introduce double counting as far as cost?
We would not introduce double counting for costs because now we have two buckets. There's the general order compliance bucket, and there's the leak abatement emission reduction effort bucket.
Okay. I also really encourage hearing from you that your air monitoring system now can be cost effective without including emission reduced from after the meter. Okay. Previously, you included that one to make it cost effective. Now that you can do it only before the meter, that's really encouraging. Here is why I feel like including after the meter kind of a little bit hard to swallow, because even though they also reduce emissions, okay, I'm not questioning that, but we have no authority to force your customer to fix those leaks. Unlike before the meter, you have the authority and go ahead to fixing those leaks. As a result, that is kind of a little bit hard to include in your cost effectiveness. So, but let give you an example. Okay, if somebody leases a building, and then that building itself full with pipes that is leaking, and then you identify leaks, they probably don't have the one leasing has no authority, or if the building owner not doing that. That's why it's so difficult to include that one in your cost effective. But I'm really glad that that one now kind of technology getting cheaper and you finding leaks faster, so becoming cost effective. But I still have a question about how effective your air monitoring to find leaks at the DMNS level. I know for transmission, probably yes, because that tend to be larger leaks. But for DMNS, I still question how effective your air monitoring system.
Okay. Well, yeah, thanks for your comments on that one. So, I mean, we do find, or we have historically found hundreds of leaks on SoCalGas equipment through aerial monitoring. So, you know, it is relatively effective in that regard. We're not just finding a few here or there over the course of a year. It is on the order of hundreds of leaks.
And the ones you're finding would largely tend to be the bigger leaks, so the more valuable at finding them and repairing them.
Absolutely. And just a comment on the customer emissions as well. We, I understand where you're coming from on that. Historically, we notify customers if we find emissions on their infrastructure, and we have seen that at a pretty high rate, they are repairing those leaks, right? They're happy to know. It is right that we cannot, you know, repair it for them, but they do tend to take care of that at a very high rate and reduce the emissions.
Yeah. For
Your calculation takes that into account, like the sort of rate at which those customer leaks get responded to. You have that data, so that's what you're working with when you're estimating your effectiveness. But yeah, when's other pointed.
Yeah.
But the jurisdictional angle is causing some people concern, but it's wonderful that you're taking a fresh look at what the cost effectiveness can be under sort of the new paradigms.
Right. Absolutely. Yeah. We made it.
Just also, I would like to point out here, fixing the MNS leaks can be costly and time consuming. And you end up into sort of a wild goose chase, because fixing one and then suddenly another one pops up somewhere. So my thinking is there a way to prevent this kind of leaks better in the future? So basically, rather than putting a lot of effort only in mitigation, how about prevention? So that way, maybe in the long run, save us some money.
Right. Yeah, it's a good point. We do have programs to replace our vintage plastic pipe, to replace it with, you know, more state-of-the-art materials that would be less leak prone. And so there are some efforts to, you know, hopefully prevent the leaks from forming in the first place as well.
Yeah,
That's
not
just
only
my head.
not only better material, but I found it a lot of those leaks occur from the main pipeline going into surface pipeline, where that T connection, or what do you call that one, when you try to distribute that gas into customer household, that usually occur there. So if you can find a better way, a better connection that we're more flexible, not easily break or causing leaks, that probably something to investigate.
Okay. Yeah, we appreciate the feedback. I'll work with our R&D group, and you know, we can certainly look into that.
Yeah, thank you for your time.
Ed Harkovich, CPC. I had a clarification question and then another question. This clarification might include your mobile surveys with the USPS trucks. When a leak is detected, either through the mobile truck or aerially, don't you on the ground verify the source of the emission?
Yes, we are verifying the source of the emission. So with aerial monitoring, we would follow up on the ground and, locate where the emission's coming from. With the USPS work, that's still more of a pilot, so we're analyzing the data, but then ultimately you would have to find that leak source.
The reason I asked about the USPS is because similarly to the aerial monitoring, there's the potential for ambient emissions as well as customer sourced emissions for your infrastructure emissions. And that's not really quantified and categorized.
Right.
So thanks for clarifying. And the question that I was hoping to ask is, when you say there's going to be an increase in emissions because of the cessation of the programs that were being funded through was it 36 or 30?
Resolution.
Something, I forget the number, but how are you, I mean, you're anticipating an increase in emissions. Can you quantify those emission increases? And if you can, it'd be good if you could give us some sort of an idea of what you're expecting.
Okay. Yeah, off the top of my head, I can't do that. And there will be some variables, right? Because you can't have years that are, maybe a little leakier than others. So there would be, some tolerance there. But yeah, it's important to have estimates. We can work on this.
So I have.
Okay.
Yeah,
Thank you.
Josh, one thing that might occur, like you said, you're not going to survey as frequent anymore. So the open leaks become longer now compared to before. So that's one of the things that we have to look at that. And then assuming the number of leaks almost similar, then you get a rough estimate for the MNS at least.
That's right. Yeah, there are a couple factors, right? There's the duration of the leaks based on programs that are surveying or identifying them, right? So if monitoring or increased survey is not finding them, they could be open longer. There's also the additional variable of leak repair. If we are repairing leaks slower, even when they are known, then there's another aspect that could result in, or we're expecting would result in increased emissions as well. So a couple things to kind of tease apart there.
To end up from,
Yeah, just to clarify on that, that the leak will be open for longer. We report emissions per calendar year, so assuming that it's been leaking since the beginning of the year. Therefore, that increase in the survey frequency won't directly, impact the emissions for that year, but it will impact the backlog, right? The number of leaks you have.
So I see where you're going with that. But for the walking surveys, because we are the miles that we cover are used in the unknown leak estimates, and if we are covering fewer miles, then we'll be estimating and extrapolating a larger number of leaks on the unknown parts of the system. So that would result in an increase in Appendix 4. The mileage is also used for Appendix 6 because the MSAs would be included in those routes. So now we would also have an increase in, or a decrease in survey coverage for MSAs and an increase in the unknowns as well over there. So those are two areas where we're expecting to see increases just based on, the numbers and the inputs for the annual emissions reporting.
and then I see there's another hand up from Renee again.
Yeah, really good discussion here, and it led to a few more questions from me. I wanted to let you know that I've had questions from ED management as to why the helicopter surveying is not duplicating satellite surveys and satellite monitorings. And I've responded that it may be because your system can identify a specific spot in your service territory and then notify those customers or those locations quicker than could be done by satellite because you know your service territory better. And so that speed of notification is one factor. I don't know if I'm right, but I'm going to give you the second part of the question, which is partly what Wynn was just discussing. do you measure the length of time between when you discover the leak from area monitoring and when you notify the customer on the ground as to the leak being on their property? And then do you look at the additional time it takes them to fix it? Because if you're going to submit this in the 28 GRC, it might be helpful to have some of that data as we at the commission are looking at this program again.
Yeah, that's helpful to know. Thank you. We do track a variety of metrics and timings related to the leak identification and when we follow up with the customer and so on and so forth. So yeah, appreciate the feedback on that. We can certainly look into how to include that with our request.
Great, thank you.
And also, a quick comment on your comment regarding satellite versus AM or aerial monitoring. So, I mean, you are right that we would be able to follow up faster than we would if it were a satellite notification. Aerial monitoring is pretty good at pinpointing the area, whereas a satellite can be quite wide that the satellite is identifying emissions from. And aerial monitoring programs are also more sensitive, so they can find smaller leaks than a satellite would.
Yeah, that's my understanding. Anyway, just thank you.
Okay. Thank you.
Yeah, this is when Renee, good to see you or hear from you in this workshop.
You too.
I really would like to discuss with you some of the thought that you have and what I have, and then let's say we can do something for the program.
Yeah, we could do that offline. That's a good idea.
Thank you.
Sure.
All right. Any further questions? Thank you very much. Appreciate your time.
Thanks, Josh.
Thanks.
All
right.
Thank you, Josh. Are you going to be using the computer as well?
Yeah.
All right. I'm going to be inviting up a speaker from PG&E who will be covering a similar topic. Just need one moment to get the correct. Right.
Thank you.
Hello, everyone. My name is Sami Ahmed. I'm an engineer with PG&E, and I'll be covering the programs driving methane emissions reductions and how we got to 52% in 2024. It's not changing. Oh, need to. There you go. I want to go quickly over the agenda. We'll cover the top reduction strategies, mainly 3. There are definitely more than that helped us to get to the 52%. We'll go over the super emitter program. Most of you are familiar with that. The meter set leak management, which was covered this morning by Sri, and then transmission blowdown emission reduction, as Wing described, the low-hanging fruit. And then we'll go over some potential for continued emission reductions, potential for emission increases, and potential for improved emission measurement and accounting. So this slide shows the key drivers, and it shows our % reduction as compared to the baseline, 2015 baseline. And we start with some kind of general measures like damage prevention, which has a primary safety benefit and also methane abatement benefit. And in 2016, we started the accelerated leak survey for our distribution M&S, going from 5 years to 3 years. Then the implementation of our transmission blowdown mitigations. And then you can see that steep drop in 2018, the implementation of the super emitter program. Then we, in 2020, started the meter set leak management classifying leaks by size A, B, C, and D, as covered in this morning. And what you see later on, starting in 2023, we started optimizing those data-driven programs that we've implemented in response to SB 1371. Probably you've seen this many times. This is the super emitter program. The concept is simple. You have 2% of the leaks in the system are greater than 10 cubic foot per hour. So the opportunity is you go after those large leaks, you find them, you fix them, put them on a faster repair schedule, and you make a bigger impact on your emissions. It was launched in 2018. We identified, prioritized like large leaks. As I said, we start optimizing it by lowering the threshold in 2023. Start 7, 2024, we went to 6, then to 5 in 2025. And we're experimenting right now with at 3 skips per hour. As you can see here, I talked about the gradual reduction of the threshold and the increase in the coverage. Therefore, we're prioritizing more leaks, not just more leaks, the right leaks that matter to make an impact on the reduction. And to the right, you see this chart where it shows as we implemented the super emitter program, you see a reduction in the number of customer order calls, which shows the safety and reliability benefit from the super emitter program. The methane abatement benefit in 2024, we reported that we reduced emissions by 239 million from distribution M&L leaks. 117 million can be attributed to the super emitter program. Again, here the meter set leak management. You can see on this picture, class A, roughly 4 cubic foot per hour. You were asking about this spread, and then you got class B, smaller, and then class C and D. Class B is smaller than class C and D. So in 2022, we adopted a leak-based bubble classification approach to estimate emissions, and then the opportunity to optimize this program is to go after the outside of the safety critical leaks, which are class A leaks and indoor class B leaks, is to go after class B leaks for methane abatement benefit. Here are the results. We achieved 56 million methane abatement relative to the 2015 baseline. In 2024, we prioritized 7,590 class B leaks ahead of their schedule, achieving 106 million in emissions reduction. And I'll hand it over to Isaac to cover transmission blowdown reductions.
Thank you, Sammy. All right, Isaac Marcia, PG&E gas engineer, and I'll be discussing the other program here. And so the transmission emission reduction program, we take advantage of all the emission strategies that are called out, when it comes to flaring, thermal oxidizing, combustion, bundling projects on similar clearance, reducing the clearance window through the uses of PCFs to install control points, pressure control valves. And, one of the main, when looking at the data, the main contributor to emissions reduction is, drafting or the transfer of gas to a lower pressure system, laterally or downstream, and then cross compression, which is really just compressing into a parallel system, and sometimes even a CNG trailer. All right, and then looking over the results of the transmission blowdown emission reduction program, the last 4 years, we've mitigated 2.8 BCF being blown down to the atmosphere. 2 BCF of that has just come from our cross compression activities over the last couple of years. And then the runner up there is going to be drafting about half a BCF. All the other different mitigation reduction strategies are in that little remainder bucket. And you can actually see the scope of work does fluctuate over the course of a couple of years. And you see The blue is going to be the emissions abated from all the different reduction strategies, and the yellow are the reported emissions across these 1, 2, and 3, and 7. So transmission pipeline, M&R stations, compressors, and underground storage facilities. One thing I do want to highlight here is that the relative percent abatement has been above 74% over the last 4 years, with a little peak right there in 2024, 83%. So compared to the potential emissions, we've mitigated 83%. So that's kind of what that ratio is explaining. However, if we do look at, the 2015 emissions number, the reporting year 2024, we were 87% lower than in overall emissions, in actual emissions, than what we reported in 2015. So whether you look at, the given scope of work for that year, or you're looking at just the overall delta since 2015, we're pretty high above that 87% or 87% compared to that number. And yeah, I would say that's pretty much it on that one. And our last highlight on the transmission or on the emissions reduction programs, I do want to pivot on to the rest of the conversation, is the potential for continued emissions reduction. So we identified a couple of different categories here. First, when it comes to the transmission blowdown program, we would like to target some of the more mid-sized clearances and take advantage of some mid-scale blowdown mitigation solutions. The challenge here is there's going to be a diminishing volume when you target smaller and smaller clearances, the low-hanging fruit analogy, and that reduces your cost effectiveness. The thing about the low-hanging fruit analogy is, even as we're targeting smaller and smaller clearances, you're still targeting the next largest clearance, right? If you're tens of millions, 1 million, 500,000, right? So that's just kind of an inherent part of tackling the largest sources of emissions. And even in doing so, you're going to reduce your cost effectiveness, but that's kind of the nature of it. And similar thing is happening actually with the distribution pipeline. Yeah, the opportunity, as Sammy was pointing out, is lowering the threshold. We're looking at 3 for this coming year, or increasing the super emitter frequency. That way, you're going to be either finding more of these large leaks faster, or you're considering a smaller amount for that large leaks. Either way you cut it, you're going to have a higher marginal cost per unit of emissions avoided, right? So you're lowering your cost effectiveness, but it's still within the ideology of you're still tackling the next largest or the next lowest hanging fruit. We like to use that analogy. And similarly, we got meter sets, right? The opportunity for mitigation there is, as Shrikant was pointing out earlier this morning, you prioritize the largest leaks, right? 17% of leaks is like half of your emissions, 53% of the emissions, I think was a statistic. And so targeting and eliminating that Class B backlog will impact or reduce your emissions. And, one of the challenges there actually is going to be these Cs and Ds, this increasing backlog of these leaks, and, the opportunistic nature on trying to mitigate those. And overall, that's the cost, the dollar per MCF, that is fairly low, as we discussed earlier today. So that is a little bit of a challenge. Moving on here, the potential for increased emissions. So when we're looking at the distribution system, there can be a potential for leak backlog growth, either due to funding constraints, delaying repairs, increasing average leak duration. I think we kind of honed in on that previous presentation on how mitigating the resources when it comes to the leak repair will increase emissions, especially from the distribution system, as pipeline leaks is the major contributor of all leaks, and especially the main contributor in the distribution system. Looking at the transmission system, it's a little, instead of population-based, it's more like an event-based situation where you can have the potential for emergency events and/or third-party damages that can significantly increase your GHG mitigation. And when it comes to, as I was saying earlier, we target the largest clearances for GHG mitigation that's built into the scope of the project, the clearance planning, everything, et cetera. But when we have a line strike and you need to figure out how to still serve customers and act safe clearance, sometimes it can be difficult to mobilize GHG mitigation technologies. And the same thing is happening, and that's some damage. Same thing can happen with in emergency events, anomalies that are detected post inline inspection. We have to take a drastic reduction in pressure, and that could also limit the feasibility and the viability of safely executing GHG mitigation for that clearance. Going on to the risks of sustaining current emissions levels, looking at the distribution system again, the reduction in the replacement program can reduce or increase the amount of leaks, right? If you're replacing less and less pipe, you're prone to having aging and older assets, and those are going to be prone to be leaking more. And so that's kind of one of the things that we see as a correlation between increasing in distribution emissions and some of the different programs that we have. When it comes to also the distribution system, we have the reprioritization of funding away from the current methane making programs. So, we're putting your money somewhere else. You're definitely going to see an increase in your backlog emissions. And this can happen through a couple of different ways: less survey frequency, delayed leak identification, and then higher just cumulative volumes if we're not prioritizing the repair of those emissions. And given that customer meter sets and distribution pipeline leaks are the largest two sources of emissions here at PG&E, we definitely see these as the largest contributors to, or the largest risks in sustaining our current emissions level. Going on to a couple opportunities, nothing too hardline here, but for improved emissions measurement and accounting, I think I did mention this in the previous conversation. I think we have a little bit of a misalignment between the emission factors for control valves that were published in the most recent 2024 EPA update of Subpart W, and we'll be following up on that via email. Thank you. When it comes to accounting, Kevin highlighted earlier this morning this integrated emissions platform, automating all the data processing of the data, getting connected directly to the database, and essentially getting a as real time of an emission reporting platform as we can have here at PG&E. And I think that's going to drastically improve our data quality and reducing the human effort it takes in reporting emissions, not just on an annual basis, but on a quarterly and even monthly basis to get those metrics. Last thing, when it comes to leak accounting, similar idea as you guys were talking about earlier, transitioning away from the mileage based to a leak-based reporting framework. It kind of goes without saying this would increase accuracy, but it would require some resources to investigate what exactly those emission factors are, whether it be investigating current established literature or doing something like a company-specific emission factor. That's something that's still yet to be investigated, but it's definitely something where we could have an improvement in an accounting of our emissions measurements. And I believe that's what I have for this presentation. So open to questions or concerns. Compliments, maybe? I'll take those.
Good job. Thank you. Yeah, you touched on something that's always been a concern to me, and that's the area of pipeline replacement programs. Obviously, benefit in being proactive, not waiting for the pipeline to develop leaks, but anticipating here's a worn out pipe, we should go ahead and replace it now before leaks start happening. Great philosophy. And it's always been challenging when my team gets asked to look at GRC proposals for pipeline replacements. The other part of what I do at the commission is looking at the cost benefit calculations. And most often replacement programs will be presented with very poor cost benefit number. And so we really struggle, like what should we advise the decision makers to do in this case? And it's often very challenging because we've come to rely on those cost benefit calculations as being a key decision making metric. I guess maybe the more that you all can do to support the benefits outside of the strict cost benefit calculation, the more narrative you can supply, I think really helps support, give support for, we've all agreed that that's not the sole decision-making number, but it's an easy one to focus on. So I would just encourage you all to think about putting as much narrative and as much like comprehensive justification, things like, how this is going to impact future leaks and that kind of thing would just be very helpful. That's my thought right now.
No, absolutely. And we can work with some of our distribution integrity management programs to really highlight how this main replacement and pipeline replacement programs affects not just emissions, safety, reliability, and all the other different things. And, definitely not cheap to dig up a pipe and replace it, but worthwhile.
Thank you.
Ed, CPC. I think, PG&E has a similar problem to SoCal Gas in that you're running into this headwind of cost benefit. When you reach for that next highest value leak, does it really make sense from a perspective of affordability, effort, and what you've been allocated in your GRC, because this is where it's going for funding, the GRC. So the conversation has to take place, whether it's a GRC filing or maybe the compliance plan. I don't know the right answer. But, what is the limit to which you're going to continue for that, to reach out for that next largest league?
Yeah, I think that totally makes sense, and I think that's a conversation that we're trying to have internally at PG&E, right? Does increasing survey frequency and finding a 5 SCIF leak faster or more often throughout the year, does that make more sense than lowering it down to 3 SCIF? And that's something that we're trying to assess in our end on, like, okay, what practice creates emissions reduction while keeping the dollar per MSCF at roughly the same. And, especially now that we've, exceeded that 40% target, I think these are definitely the conversations that we're looking to have. And as I was saying earlier, like the risks to maintaining our current levels emissions reduction, because it could be the case of just, yeah, we've hit the limit, right? Maybe it's 50%. Maybe there's new regulation that says now the target is 60%. I think there are a couple different factors that affect where that line is and where we should stop reaching for the next highest thing. And definitely there's going to be some operational aspects of it. Like we can't just go ahead and repair every leak, especially if they're small. But I think that's a developing process. And, we're looking at that, whether it's, as I was saying, blowdowns, meter sets, distribution pipeline leaks, that type of when do you reach for the next lowest hanging fruit is a conversation we're having at all different levels, across the organization.
And I agree, it's gonna cost more to abate the next MCF, right? But what we're doing is trying to find the most cost effective out of all the options. What is the most cost effective to get that next MCF?
Right, but is the most cost effective, still cost effective in the whole larger scheme of things?
Yeah, that's
Where you're spending less money to get that next MSCF, but it's still too much money.
Yeah, I think that does.
MSCF.
I think that
So that's the conversation, because, there's the conversation with Energy Division, when you file your GRC, what will they be willing to fund? What's the cost benefit ratio that we're going to be seeing in the compliance plan filings? Those kinds of conversations is, now that we've reached the initial goalposts that were set out in 1371, conversation has to take place to, well, how much farther are we going to run the ball before we decide to devote or spend our resources in other areas? Because there's other safety concerns within your larger utility. There's other concerns, larger society, about these natural gas leak emissions. Does it benefit society as a whole to get that next MSCF, to spend that much money, or would we be better off spending that money doing something else within the utility itself, either for customer service, other risks that the utility is facing, and so on. So that's the question. I think that we're a small little ecosystem here, talking about one small thing, and we're still part of the larger picture.
agreed, but what we're looking at, I guess, I use meter set leaks. We're using the same funding, but we're spending it now on Class B leaks. It's actually, in that case, we're making it more cost effective to repair leaks. We're looking at, when you talk about the super emitter, we're thinking, instead of fixing a grade 3, a below ground grade 3 leak, which doesn't emit a whole lot and has a very high, very low cost effectiveness, then should we lower the threshold and identify more super emitters at a lower cost? So that's what we're talking about. We're spending the same, we're just reallocating the dollar toward more cost effective programs.
So you're using the same pool of dollars.
The same full dollar on looking at the program as a whole, as you're saying, and optimizing it. So like we're looking at Class D leaks, they're too small. They don't have a very good cost effectiveness. We're like, all right, let's eliminate the backlog of all Class D leaks and increase our cost effectiveness.
I see what you're saying.
Yeah.
And similarly, as we're going through the compliance plan process, we're seeing that gradation of cost effectiveness across the different programs, right? Same amount of dollars, are we going to invest more blowdown reduction, or we're going to,
Yeah.
invest more in super emitter, right?
Within the same methane abatement driven programs.
If I take my CPC hat off
Uh,
and I'm your boss,
Okay.
I say, well, let's stick with what we've got as far as our emissions. So give me that money back. I can use it in another program, that going over here.
But then you,
And maybe I need to replace more electrical poles in the high fire risk district. And, or do more under the pipelines, gas pipelines. Well, excuse me, electrical transmission, sorry. Took off my CPC hat and I put on.
and I'll tell you, boss, we're gonna reverse our progress in methane abatement. Because you report per calendar year, if you stop repairing leaks, we're gonna go backward. And
That,
yeah,
I think that's still a conversation that needs some thought and debate,
Right.
because even though, you know, there was a discussion about, you know, calculating your, unknown leaks. Well, because you haven't surveyed and found the leaks, now you're estimating the leaks. So the delta between what you detected or what you didn't detect, but you think still exists, isn't that big. If your estimation of the unknown leaks is fairly accurate. So there's not going to be a huge change or increase, might even be a decrease depending on your algorithm for calculating unknown leaks. So I just throwing out there that these are conversations I think that, you know, and I don't know, I'm not a decision maker, but in my view, would need to take place for the next phase of the NGLA program. Where did we start allocating our resources? Do we want to go for that next highest leap? Assuming that there's a marginal cost increase, because you mentioned that every MSCF is going to have an incremental cost. It's going to have some associated costs. As the leaks go down, the cost benefit goes down.
Yeah.
And so there's a trade-off there. And so these trade-offs are going to be part of the discussion in deciding where this program goes in the future. Now, I don't know. Maybe you continue down this road. Maybe it's something that is a high priority. We see that allocating our resources in this way is best overall for state health. I'm just throwing out there that I think these are discussions from my point of view that where we talk about those the next largest leap, the incremental costs go up as you go for smaller and smaller increments. So that's all. Sorry.
Thank you. No, thank you for that.
No, I appreciate the commentary, and I think that's very apt observation of where we're at, right? Especially as you were saying, we hit the checkpoints. Like, let's look around and reassess where to invest the money. Especially, I appreciate the holistic utility view as well, right? Thank you. Is there anyone asking questions online?
Oh, Win has his hand up. Hey, Win, go for it.
Yeah, gentlemen, what we discussed just yet, what economists call the law of diminishing return. Okay, something that we need to think about. Okay. But look, I have a question here about your blowdown. Like you said, this is low-hanging fruit. Walk me through, okay, how you consider the blowdown emission something legitimate as gas saving, in the sense, who will approve that, yes, this is needed, this must be done, and then as a result, this is the quantity that makes sense from that blowdown. Can this kind of activity causing a double counting, meaning, okay, you blow down once and then, oops, yeah, actually we need to fix this one together, but since already blow down, that gas is already safe. Okay, no problem. Gas already safe. Then you count another blow down that actually can be avoided if you plan it accordingly. Walk me through the process. who you need to contact that this kind of blowdown is legitimate and they be counted against your baseline?
No, I think that's a great question. So first off, we assess GHG mitigation based on the feasibility of execution. As I was saying earlier, there might be issues with some or even planned blowdowns. I think we're also going to be, what size or who considers it? What are the decision makers here? So we're typically targeting blowdowns greater than 1 million cubic feet for assessment for cross compression, and then within that, there can be tens of million cubic feet of void through cross compression. And this is typically based on known scopes of work, pipeline replacement, inline integrity upgrades to the pipeline as well, maybe even station rebuilds or, valve replacements, some of these big stuff. We can anticipate that we're going to have millions of cubic feet blown down. That's going to have a substantial increase on, our reported emissions. If we're looking at 2024, for example, we're at 85 million across the entire appendices 1, 2, 3, and 7. And so, the second we crossing that 1 million range, 2.5, 5, 10, that's when we see the orders of magnitude of added emissions start to increase on essentially one clearance. And so that's typically an approved, funding at a project scoping level. And, of course, GHG emission strategy, we encourage to take advantage of these, greater than 1 million cubic feet because the return or the dollar per MSCF, we're focusing there. We're typically not targeting some of these mid-scale or smaller blowdowns for mitigation due to the incremental costs in getting that MSCF, mitigating those blowdown emissions. And, I know you also mentioned the concept of like project bundling. That is definitely something that we take care of, typically at a portfolio level. When the project management, there's groups within project management that look at and assess what projects are in a region. So if we're going to be doing some upgrades to, Napa Valley, it actually saves money from a project perspective on planning, engineering, construction, to have that same team work on that series of projects along the, whatever section of whatever pipeline, and then to consolidate as much work as possible. There are advantages to be gained in targeting same system so that we don't have to come back there next year and take a blowdown on the exact same stretch, right? If we can do a pipeline replacement, an ILI upgrade, and install something else, valve replacement, obviously we're going to want to take advantage of that, and we do take advantage of that as much as we can based on the approved funding that we have and what is most critical to get replaced from an integrity standpoint or just a demand standpoint. And I think there was a third question in there about, I don't know if you could help me. I think you had another third part to that.
Yeah, no, I think you answer all my question there, except still not clear to me who you contact before you get approved. Yes, go ahead to this blowdown, and then is there anybody to verify that kind of amount of gas being cross compressed?
Yeah, we do have multiple methods of verifying the amount of volume. There are meters on the cross compression units itself, as well as our engineering calculations on, I think it's equation 14A or 14B in sub RW, the load and volume equation, where we can see the SCADA trends, we can see the pressure across the different system, and then as well as the isolation window. So we can quantify the amount of gas that was compressed, and at what point do we see a blowdown, and all those recorded pressures and volumes are in there. So and also that can be compared to what we're having on the actual meter that's on the actual cross compression units. So there are kind of two ways of verifying the amount of volume that's mitigated. And I think, who is the ultimate decision maker? I would say it's a confluence of different factors. Operations. Can we take this clearance? Can we do mitigation? How much mitigation? Oh, there's congestion in that one area because it's the peninsula and there's 18 other projects. There's definitely many factors of it. Project funding, clearance, feasibility. Our operations and maintenance resources. Whether or not the cross compression units are available. We only have 8 of them. If there's a bigger job, it doesn't make sense to handle the 1 million job if there's a 20 million job, somewhere else that needs all those resources. So I'd say it's holistic and it's multi-factor feeding into what makes sense for GHG mitigation.
Who in the government entity that you need to contact to get this kind of permit or approval? And then who you contact to verify that, okay, this amount of gas actually safe or cross compress?
I'm not sure I know the answer to that question. I know for a fact, that our cross compression team does have contacts with some different air districts, prior to some of their cross compression activities to ensure that, the proper emissions are either being avoided or communication of those large blowdown events if we do have them. But I can't really say for sure, who's the actual contact person and who in on the regulatory side they're contacting.
Okay.
But we can probably follow up with you via email, once we do some research on our end though.
Okay. And then I don't know if this question for Sammy or for you, with regard MSA, is there a way or down the road in the future design MSA so that less connectors, less prone to leaking, make it as simple as possible, sturdy enough, and not as costly as technologies getting better to have that kind of design so that you not keep repairing the same old stuff over and over, and it's not as cost effective.
Yeah, I think Monique wants to answer that question.
Hi, Lynn. It's Monique with Gas R&D. I can take that one. So our gas meter services team is actually doing a pilot on that using the Joe Martell piece. I talked about it last year because initially R&D was going to fund that, but since they have the expertise, they actually took that project. But basically what it does, I believe, is it cuts down the connectors by 15%. So they're piloting that right now to see if that'll help reduce the leaks, because like you said, theoretically, if there's less connections, there should be less leaks.
Thank you, Monique. Keep us posted.
Yep, will do.
Is there more questions?
Thank you.
On there?
I don't see any other hands up. Somebody in the room? Yeah, Josh.
Josh Sanford, SoCal Gas. CGD. So, great presentation, guys, and I see you mentioned the Appendix 1 mileage-based factor as well as a potential enhancement. And so I was just thinking while you were talking, SoCal Gas and SDG&E uses mileage-based estimates. PG&E does. I think Southwest does as well. In order to be most cost-effective and efficient, is the CPUC open to us? What if we pulled data into the California utility emission factor? Is that something you guys would consider?
Yeah, I think we'd consider it. We want to look at, I think your study would have to have some element that demonstrates there's no sort of significant geographical difference or significant material difference between the companies so that you could develop a unified emission factor. I would also think, I think we saw some preliminary data, maybe it was PG&E had started studying, I think for the Appendix 2 changes that we made last year, somebody had done a partial study indicating that your own results would be significantly lower than the EPA number that was out there. But they hadn't completed the study, so they didn't want to let's adopt this one. It's not finished yet. I apologize. I don't remember which company had done that, but just even presenting that partial data went a long way to convincing us that, wow, at least, the EPA numbers, which are significantly lower than the ones that we had been using, that was a strong, push to okay, well, at least adopt these EPA numbers for now. And I think, if your joint across California study, showed something similar where, whether it's SoCal's, transmission pipeline or PG&E's transmission pipeline, this data is an order of magnitude, for example, lower than what's in use in our Appendix 9 now, or, that might be, indicative of a great move forward, even if like it isn't absolutely specific to one company or another. But I think those are some considerations, like do something in the study that kind of gives us a sense of how similar the different companies' data is. And yeah, I think probably very good reason to adopt a single California EF. Obviously that would help you compile enough statistically available data points collected together instead of each company having to individually collect, I guess, potentially hundreds of samples, right? So yeah, you guys are free to talk to each other and come up with something.
I think if anything, we'd probably prefer a California specific EFs, if you also want to loop us in on the study design itself, I think that would be helpful too, just to make sure it's, robust and, what we're looking for.
Great.
Anybody else on the call?
Yeah, we have another comment from Win.
Yeah, I just want to second what Jonathan just said. Okay, involve us early on, and especially if you're going out in the field measuring something, let us know. We probably would like to participate and would like to know more about how you collect the data, measure the emissions, that kind of stuff. We would really appreciate it.
Like a field day during the process of collecting samples, give PUC and CARB a chance to just kind of become familiar with, observe the process of how you're doing it, would be awesome. That would be really good.
All right, then. Thank you.
Good. No questions?
No, none.
Okay. Thank you.
Thank you, guys.
Thank you.
Should I just close it?
Okay.
Thank you very much for that presentation and those great discussion as well. Right now, we have scheduled a presentation from Sempra. So I'd like to invite the SoCalGas SDG&E team up on a presentation on their R&D.
Good? On sound?
Yeah, you're wonderful.
Well, good afternoon, everybody. Thanks for hanging in there. My name is Eric Rodriguez. I am the Gas Emissions R&D Manager for SoCalGas. Today, I'll be doing a quick overview of the projects that we completed during this last cycle here on R&D for the Natural Gas Leakage Abatement Program. There we go. So attached here is the agenda. For the sake of time, I'm just going to jump right into the projects here. So starting off, we talked about a little bit earlier that Josh alluded to is the passive mobile methane detection project. I talked about this briefly last year, but essentially the concept is you attach simple methane devices, simple meaning no anemometer, just the methane concentration device, to a vehicle that has repeated mileage coverage. In this instance, it is the United States Postal Service vehicles. You can see in the picture there on the bottom, the intake for the sensor is mounted to the front of the vehicle, and that black box is the actual processing unit that's located within the vehicle itself. We did a pilot study, or in the middle of a pilot study, where we have 37 of these units out in territory within our jurisdiction. And we started collecting data around August of 2025. There were a lot of delays with the vendor and getting the approvals for the install and things like that for the sensors. But since then, now we have a few months worth of results that I'd like to go over. Results for August, for example, we had 5 indications. We did perform follow-up investigation and found no leaks.
gave that feedback to the vendor. September results roll around, 4 indications, one of which was a system leak, 3 no findings. So from 0% to 25% hit rate. October, 15 indications, 2 of which were customer house line leaks, 4 of which were system leaks. So now we're getting closer to that 33%. And then November, 24 indications, 2 house line leaks, 12 system leaks, 2 field gas, 8 no findings. Now we're getting close to a 50% hit rate. This has been improving for 2 reasons. One, I think you touched on before, Ed, as you get more coverage over the same area, you have a better understanding of the nominal profile of emissions within that area. So it's easier to recognize an anomaly. So now when you're looking at the data, you can know when there's something that should be investigated. And then additionally, as we perform our investigations, we're providing that feedback to the vendor, and they're using that to further refine the algorithm. So in the top left corner there, I have for you an image of what this kind of product looks like when it gets delivered to us. It'll show the indication of the overhead view on the map, general area where they think the emission's coming from, a table that shows all of the different dates and methane elevations that were picked up at those locations throughout the time between different reports. And then that's something that we built similar to our aerial program so that it's easier for us to go out and quickly investigate and find something. This is another project I touched on last year, which is improving the cost effectiveness of the aerial methane mapping program. For that program, there are polygons that are flown, and typically when the helicopter is being ferried from the hangar to the polygon and then back, the sensor is left off, but you're still paying for the time for the pilot, you're paying for that fuel. So if we ran the sensor during that time, it should be a smaller incremental cost, and you should be able to have a better cost effectiveness associated with that portion of the data collected. We did this for a 6-month period when the AMM was routinely operating. You can see that we covered almost 1,100 linear miles, 146 indications were picked up. The profile of which is provided there in that donut chart. It's very similar to what you would expect from the standard aerial methane mapping program. And then I have a table there where everything is separated out based on which sources are included in the cost effectiveness calculation. I think you'll appreciate that one. So you can see there for system leaks, it's about $10.81 what we came out to. I will note that this does include the shift from 1 year to 3 year for unprotected steel. So that's already incorporated into it. This is another project we touched on last year, which was, we have all this data that we've collected from the aerial methane mapping program and all these verified customer emissions that we found. So the thought process was, if we took this data and used it to train our current advanced meter algorithms that are missing these leaks, could we improve them so that the algorithms could find it on their own? And so we took that, trained the algorithms, and then validated them against that same data set until we got to about a 95% correct identification rate. We then took those algorithms and applied them to 4 years of historical data for areas that are not covered by the AMM program. And when we did that, we had about 6,000 indications of potential anomalies. We did not have the funding available to investigate all 6,000, but we did a single district, and in that district, there were 19 visits, and that is a breakdown of the results from those visits. So you can see 16% were related to gas leaks. Note that these are customer-side gas leaks. Interestingly, 26% were related to hot water leaks. So this is where there's a leak on the water system and excess gas is being consumed to heat the water that's being used to replenish it. And then, of course, there's some normal consumption and some that were related to circulating water heater pumps. If this work were to be continued in a different program or initiative, I think we would collect more data to get a better feel for the investigation results, and then fine-tune those algorithms to perhaps filter out some of those normal consumptions or circulating pumps. This is something, again, touched on last year, which was the cost effectiveness framework. I think you'll remember, Fred, you commented on the formula being quite long. I've shortened it all into that one NB term there, net benefits term. Underneath it is that huge formula still. This is just to cover that we finished the final report on this framework. We also created a supplemental report where we applied the framework to a previous project, for example, the AMM project, to show how it would look like. This has actually been handed off to the Greater Gas R&D program at SoCalGas for further refinement and incorporation into an EPIC framework, which as we've been directed to do. So this is great that this work is being continued and moving forward for that directive. This is another project update from last year. So we covered where we were looking at pipe thread sealants and the different kinds of sealants that could be applied for storage applications, which are high temperature, high pressure. We looked at 16 available thread sealants. When we did the testing, all the paste failed during high temperature testing. Only 3 tapes passed during the pressure and temperature cycling testing in the lab. We then started a section of longevity testing where it was going to be 6 months under 300 degrees Fahrenheit temperature, 3,400 PSI conditions. So those 6 months have passed from last year. And after all of that testing, one of the tapes did fail. Only 2 remained completely leak proof. One of those was standard plumber's tape. So that is, it is a very good sealant when applied properly. Now,
I'm curious, I mean, so you got all these products from different vendors. I mean, there must have been some vendor claims about what they were stating they could do, or maybe you were trying to push them beyond.
we pushed it to the limits, right? We're pushing it to very high temperature, very high pressure conditions that you would see for both the gas side and the glycol side of storage, because ideally you would have just a single sealant that you could use. So there's no confusion and the wrong sealant not applied where it shouldn't be. And so under those conditions, yes, a lot of the sealants did not perform as well, but it might be outside of their
Product envelope. Yeah. Oh, well, that's good. You found 2 that worked.
Yeah, and one of them is plumber's tape, funny enough. And then the last thing we go over is the meter set assembly failure mode analysis. So this is branching off of the work we did looking at our company-specific emission factors we developed for Appendix 6. During that, we had broken it out into leakers and non-detected leakers. That is, leaks that are so small they aren't typically found during a normal survey, but they were found during the CARP study, for example. And so I combined them into one chart for the purpose of this, because if we're addressing a failure, I'd rather address all the leaks within that category and not just the larger ones. And so again, just as a refresher, the dark blue is the quantity of leaks within that category associated with that component, whereas the lighter blue is the overall emissions. So just because something is a higher quantity doesn't mean it is emitting more. So it could be a high number of very small ones, as you can see with the insulating bushing. So going through them one by one here, I say that and then I combine them in the first slide. So insulating bushings and valves. These 2 valves especially were something that we found was related to the longer a valve is out there, the stem is able to dry out, a lubricant in the stem seal can dry out, and then it starts to leak from that valve stem. And so a potential solution that we came across was an ISO 15848-1 certified valve with the built-in insulating bushing. So this is a standard that tests to 150 degrees C, 12 bar conditions, 200 cycles on these to make sure that there are no fugitive emissions from the stem seals and the body joints. And so these are valves that actually have no lubricant. They just are leak-proof through those stems. This would address roughly 138,000 MCF per year based on the last emissions report from these 2 categories. This is actually an interesting one because looking at it, you can actually remove some components potentially in the design. And so now you have what used to be 2 components can become 1. There are potential cost savings associated with this, where this is a solution that could be pursued and the emissions reduction is actually just a side benefit of it. The threaded connections. So threaded connections, high quantity, high emissions. This is a category where we looked at, as I mentioned, sealant selections, application techniques, torques, different types of fittings. Threaded connections are very difficult to prevent emissions from because in a lab, it's very easy to control torque, very easy to control application. When you're out in the field, maybe you're in the dirt, sand, things get onto the sealant, get onto the threads. Your space that you have to work with might be very constrained. You might not have enough leverage to apply proper torque. It's very difficult to consistently create a leak-proof thread. So the best solution, as PG&E talked about as well, is just designing it out. So the fewer threaded connections you can have, the better. Monique mentioned earlier this fitting here, which we are also looking at too based off of their findings as a potential way to reduce the number of threaded connections there. And statistically speaking, if you reduce your threaded connections by half, you should reduce your emissions by half, purely from statistics. There's also other potential benefits from these. easier to assemble in the field, means it's less work, less time. So there's a cost savings associated with that. And then additionally, if you have to do a repair or replacement, your components should also lead to a potential savings as well. Next up are the regulators. So for regulator emissions, one of the potential solutions would be a two-stage non-venting pressure regulator. This category is a bit smaller on the emission side, only about 51,000 MCF per year. From a cost analysis, a rough estimation shows that this would be difficult to do at a cost effectively unless you had additional benefits associated with it. There are emissions from normal venting under normal operation from these regulators, but to my knowledge, no one has ever done a study on what that quantity is. There is one underway through a consortium, but there still aren't any results from that. So this would be one to just keep an eye on. Better to focus on the lower hanging fruit up front. And then finally, the ultrasonic meters, or sorry, the meters themselves. So one of the potential solutions for these would be an ultrasonic meter. This addresses about 143,000 MCF per year. The big advantage of these meter sets would be, one, the pressure sensing provided in them, because that could have additional benefits associated with amplifying the advanced meter algorithms I talked about earlier for detecting customer gas leaks or hot water leaks from a data analytics standpoint. And then in addition to this, besides the meter itself, one of the big issues that we found for meter leaks is the swivel nut connection on the top. If you would, because it's a gasket, you're not really meant to open and close that more than once, really. And so over time, those can leak quite large amounts of emissions. And so one way to reduce that is pressure sensing within the meter itself. Or if I go back a few slides, you'll see some of these valves actually have built-in bypasses on them, which is kind of nice because now you could attach a pressure gauge directly to the bypass, open the bypass, and take a reading without having to make that connection, remove that connection on the swivel nut. So just from an operational standpoint, we could actually potentially address that even with this valve solution. So that kind of alludes to what I mentioned about there being a cost savings and the emissions being a bonus associated with this component redesign. Future work, so pursuant to the resolution G3605, SoCalGas will move its natural gas leakage abatement research demonstration development projects as appropriate to the broader R&D program in the next GRC. And these projects will, the ones that will be continued, will be incorporated into new and existing initiatives within the broader research and development program, as is appropriate. And then that's my presentation. Any questions?
It'd be nice to see, do we have a picture of what the new, say, piping arrangement, the set of fittings, et cetera, for this
I have one, just not in the
style
slides. Yeah.
NSA? That would be interesting to see at some point. And I'm not familiar with how existing meters actually do the measuring. Is it like a mechanical rotating thing that's
Yes. Yes.
figuring out how much gas is flowing through it? And so that's replaced by this ultrasonic device?
It's a potential replacement. This is one where, again, a lot of it has to do with some of the emissions came from the body itself having some sort of defect,
Right.
or the flange and the diaphragm having a leak come through. But the majority really of those larger emissions really came from that swivel nut connection on the top. And most of the time that's opened up whenever there's some maintenance that needs to be performed on the meter set. Typically they take pressure readings through there. So this could potentially also be addressed simply through the valves, as I mentioned earlier.
Right, so you wouldn't necessarily be solving that problem. It's not the only way to solve that problem.
Correct.
By going to this. You could actually have a different
Correct.
solution there.
Okay, Ad hoc pitch, CPC. So it wasn't clear to me if those fittings were already in production or if there was something you were designing or as a what if they could do this.
They're already in production and available from the vendor.
Okay, so then you can do a cost analysis of the pieces versus what you normally stock.
Yes.
And then the next follow-on question I have is, what would be your meter replacement paradigm? And because you already have an inventory of meters in stock, you've got to work through those. You've got meters that are still working and fine. Is this going to be on an exception basis? As one fails, you replace it? Or how
So-
do you envision this being rolled out?
So that would be, I guess it depends on what kind of cost would want to be spent. If it's something where we're willing to just roll it into the standard meter replacement program, it would take a lot longer, obviously, to go through there, but there wouldn't be any additional costs essentially associated with it. If it were so desired to accelerate the process of those replacements, then that's probably something we'd have to pursue through a funding mechanism in the GRC to accelerate that meter replacement.
Would this be part of your filings with, I don't know, through the compliance plan or the GRC?
You have to be a GRC
GRC.
filing now.
Okay.
I would guess in many cases, the leakage from an individual meter of these kinds is a pretty small number. So it'd be hard to justify an overt replacement program where like, yeah, we're gonna go in and tear out a fifth of our meters every year and, replace them with all this new hardware. Might be very difficult to show. Cost benefit may be more realistic to really just gradually work it in. And every year, whatever portion of meters would routinely get replaced due to wear, age, failure will gradually give you the benefit of these.
That's absolutely right. And, there might be some work where communications hubs are at the end of life and they need to be replaced. If it can be incorporated with that work and coupled, that can also help accelerate it without a specific program. But with 6 million meters in our territory, you're right. It'd be even with extra funding, it's a mountain to climb.
Yeah. But it's cool that you're investigating that.
Kevin from PG&E, do you have on the meters, the ultrasonic meters, do you have a sense of the improvement in accuracy you would expect?
That is actually a different group that does the meter accuracy reporting, so I'd have to defer to them. I don't know off the top of my head.
We have some raised hands online. When do you want to go first?
I would defer it to Renee first because I asked too many questions already.
Well, thank you, Win. I appreciate it. I'm interested in that a bullet that you have, that the emission reduction potential of 143,000 MCF per year. Was that a vendor supply? What are the assumptions on that? Did that result from your tooth?
That's from our research. So it's from our Appendix 6 emission factor development. It's basically a portion of the components, the portion of the leaks when we did our statistical sampling that were attributed to that specific component being applied to our Appendix 6 emissions that we are reporting for the meter leaks category. So essentially saying, I know that this percentage of my emissions is coming from meters. So if I look at the emissions I'm reporting, this is what will be attributed. From a statistical
Okay,
standpoint.
it kind of goes to your discussion with Fred in that you're not going to be able to replace them all at once. So you would have to come up with your strategy and targeting certain types of, are there any climate variations in their failure modes? In like hotter parts of your service territory or?
There's some variations, but it's small from what we found. I mean, you might see more attributable to corrosion in some climates closer to the ocean versus those closer to the mountains. But those were by and large still significantly smaller than the failure modes that we see as a systemic issue across the territory.
Okay, it's my understanding that a lot of that there's only a couple of manufacturers still making the old kinds of the non-USAs. So I'm wondering, what your take of the market is for ultrasonic meters. Is this what is going to be more commonly available in the future?
So I'll first answer as a research engineer, and I love data. And so this gives me more data because I get pressure measurements over time. So I would love to have these everywhere because I have more that I can do with what we have out there right now. From a supply chain standpoint, I can't speak to that. If the manufacturers are winding down, which I have heard as well, that's obviously going to play into the cost dynamics of whether this is more cost effective to use the ultrasonics versus the diaphragm meters. I think as the cost comes up for the diaphragms, naturally that makes the ultrasonics more feasible.
Okay, thank you.
When? You still got your hand up?
I think Mike should go ahead.
Well, I had heard the same thing about manufacturers largely moving to the ultrasonic space, and I think there's good financial reasons that they would want to do that, just given product life cycles. And so it also adds a lot of advantages for gas companies, the data we get back, the richness of that, some of the safety features. I did want to kind of ask, you had made a comment earlier about one of the aerial patrols and finding, I guess, unburned gas that was coming from water heaters. And I just want to confirm I understood it. That was essentially, since you were flying over, I assumed that it was coming out through one of the chimneys or one of the exhausts off the top of a roof.
Excuse me, who's speaking?
I'm sorry, this is Mike Cairns with Pacific Gas and Electric.
Thank you, Mike.
This is actually an interesting one. So what actually happened was we had flown over aerial. We had found verified customer gas leaks. We took that data and we recognized that those leaks that we were finding were not being detected by the advanced meter algorithm. And so we trained the algorithm on that data. As a byproduct, when we applied that to those algorithms, we ended up finding water leaks on investigation, which is interesting. So this is something that is a bit new to us, where when we went to go check out if there was a gas leak there, we found the water leak. So it wasn't being picked up by the helicopter, it was only being picked up by the algorithm with abnormal consumption on the meter.
Oh, that's really interesting. I'd love to dive into that a little bit more at a future point in time. Thank you.
Yeah.
All right, when did you want to go?
Okay, if nobody else, yeah, I really would like to ask Eric. Eric, very interesting to see how you try to design your bushing. I also would like to share with you again our study about 8 years ago about customer meters. We went out and every single meters we inventorize how many elbows, how many connectors, how many bushing, all kind of stuff. And interesting enough, bushing, even though not the most common part installed in each meter, 20% of we surveyed leak. Okay. So as I said, not every single meters has a bushing. So why not design something without bushing if you know it is causing trouble?
Yep, exactly right. And that's exactly why I'm proposing this valve that has the built-in insulator. So if you need that insulation on that meter set, it's now all a single component, one that is less likely to be exposed to the elements, become a plastic brittle piece that breaks and causes a leak. So
yeah,
that's exactly what I'm looking to address here.
That different material between metal and plastic with different properties, causing a lot of problems. And then this is just to wake everybody up, okay? Is there a way to be a more trusting between gas provider and consumers so that you can get rid all of the meters. Each month for summer, you can charge this much, and then for winter, this much. That way you get rid of the survey cost, all that kind of stuff, given plus and minus, okay? Some customer maybe cheat a little bit, the other one may be using less a little bit, so in overall, maybe break even.
So that's funny. Actually, so the apartment complex I live at, they have a third-party vendor that charges for the aggregate water use of the complex. But you don't get to see any meter gauges or anything. You just get charged an amount and you're assuming it's correct. I think a lot of people complain about that. Actually, I know a lot of people complain about that. I'm not sure how perceptive the public would be to not having that insight into their consumption. You know?
Anyway, thank you.
Any other questions? Thank you.
Yeah, Eric, before you go,
Sorry.
about your tape, okay, how difficult it is to put it in practice, because unlike the one you tested in the lab or something, the one out there could be dirty and then dusty. How much effort you have to clean before you sure that the tape will stick properly?
I mean, I personally think it's impossible to get consistent sealant performance out in the field on these starter connections. There's just too many factors that between the individual, between the application, between the environment, windy or dirty, or you're cramped. There's just so many things that could go wrong versus having it as one manufacturer that gets
I
installed.
agree with you. I agree. And then exposed to a sprinkler system, get exposed to sun, all kind of stuff.
Ideally, right, it's one whole piece that you could just install, and then you don't have to make any connections out in the field. I think that, you know, you can have lab graded conditions where you're creating all these connections and you can QC them. Yeah, that would be the probably ideal future space. But then, of course, if there are any issues, now you can't really address it in the field without replacing the entire assembly. So there's some trade-offs to that.
Okay, give it some more thought about charging a flat fee without meters.
Any other question? Thank you.
Thanks, Eric.
All right. Thank you for that presentation. I don't have the agenda right in front of me, but I believe that we're scheduled to have a short break, just to give everyone a chance to stretch their legs, go to the bathroom. We only have a couple more presentations after this, but I think it'd be good if we took a break. I'll give everyone 10 minutes. Just come back and we'll say 3:05. Sounds good to everyone?
Did you send me the note about security?
Yeah.